Hello, the Math Dog here. So this video could really be, I have it listed as grade 6, could be really anywhere grades 5 to 8. And it's on the area and perimeter of a parallelogram. So please look at my video on the area and perimeter of rectangles before watching this video. And also it would be helpful to watch my video on classifying quadrilaterals. This video again is not to be shared or reproduced without the written consent of the creator. That's myself, the Math Dog. So what is a parallelogram? By definition, a parallelogram is a quadrilateral, quad for four sides. So quadrilateral is a four-sided enclosed figure with opposing sides being parallel. So I have written down here, this says segment AC is parallel to segment BC. So segment AC, line segment AC is parallel to BD. And I wrote that wrong. Notice here that's not correct. That should be BD, not BC. So let's fix that. And then AB, segment AB is parallel to segment CD. So we'll talk about that in just a second. Notice I'm naming this parallelogram as I go around it. I'm going around it clockwise. Parallelogram ABDC. You don't have to start A, you could start at B. In fact, you could start at D or C. You could either go clockwise or counterclockwise. I could call this parallelogram BACD. So I do talk about that in more detail in my thing on classifying quadrilaterals, my video on classifying quadrilaterals. So again, note that this little railroad track sign means parallel. This means segment AC. So again, by definition, a parallelogram has two pairs of opposite sides that are parallel. Here's a pair with the single arrow means those are parallel, double arrow means these two are parallel. So some other properties of parallelograms, we will state these without proof here. We don't have the properties needed to prove them yet. So one, opposite sides of a parallelogram are equal. So not only are they parallel, they are equal or they are congruent to each other. This equal sign with a little squiggle on top means congruent. Congruent means same shape and size. So if I took segment AD, for example, I could place it over segment BC and they would perfectly match each other. So segment AD is congruent to segment BC in this diagram, and segment AB, line segment AB, is congruent to CD or DC. It doesn't matter which way. Segment CD and DC are the same because it's just, you can name it either from left to right or right to left. So also in a parallelogram, opposite angles turn out to be equal in measure. So angle A is congruent to angle D, and angle B is congruent to angle C. Alright, let's talk about rectangles and parallelograms for a moment. A rectangle is defined as a quadrilateral, four-sided enclosed figure with two pairs of congruent sides. It should say two pairs of opposite, or I should say two pairs of congruent sides that are opposite each other. And four right angles. So here's a pair of opposite congruent sides, and here's a pair of opposite congruent sides. It can also be shown that a rectangle has two pairs of opposite sides that are parallel. So it turns out that these sides are congruent, but they're also parallel. These sides are congruent and they are parallel. So we can say that segment WZ is parallel to segment XY, and segment WX is parallel to segment DY. So this means that all rectangles, in fact, are parallelograms. Okay. But note that not all parallelograms are rectangles. You could have a parallelogram that looks something like this. That's not a rectangle because these are not right angles here and here or here and here. So this little sideways U means subset of. So rectangles, and you can see in this Venn diagram, are a subset of parallelograms. all rectangles fit inside the classification of parallelograms, but there's parallelograms that do not fit do not fit in the category of rectangles. Like there's a thing called a rhombus. A rhombus turns out to be a parallelogram. It has 4 equal sides, but these don't necessarily have to be right angles. Okay, let's talk about altitude or height. Altitude means how high something is. So examples, Denver, Colorado is called the Mile High City because its altitude or height is about 1 mile above sea level. The jet was flying at an altitude of 30,000 feet above sea level, meaning it's up there 30,000 feet above the level of the sea. Okay, also, so I have here an imaginary ceiling, an imaginary floor, and I've dropped a rope right here. Let's assume that rope is perfectly straight, but I'm calling this is actually segment AB here, the way I've done it in a diagram. I've drawn a circle, and this would also be a radius of the circle, segment AB. Radius is a point from the center to is a segment from the center of the circle to a point on the circle. So this rope is also a radius of this circle. Okay, then I've drawn these segments right here. I guess I should call this, give this a name here. I'll call this segment, let's call it AC. This is segment AD. If you notice, you can see that segment AC is longer than a radius of the circle because a radius of the circle would go from A to here, and AD is also longer than the radius of the circle, which would go from A to here. So you know that segment AC is longer than AB, segment AD is longer than segment AB. So what I'm trying to show here is that the shortest distance from a point not on the line, I'm calling this A, to the line is what's called the perpendicular, and this rope intersects the floor at a right angle. So perpendicular means intersects at right angles. So the word perpendicular means intersects at right angles. Instead of having to write out all the time, we'd put an upside down T to represent perpendicular. So in the diagram above, segment AB is perpendicular to the floor, which I'm representing with segment XY, or actually with line XY. So let's now finally talk about deriving the formula for the area of a parallelogram. So we start with a parallelogram. We draw an altitude at one of the vertices. So here's a vertex. I drop a rope or drop a line straight down to the bottom here of this parallelogram, and it intersects the bottom at a right angle. So this is the height or altitude of the rectangle, this distance from here to here. We call this the base from here to here. There's 2 bases, there's another one up here. So what I do is then, so I'm highlighting this, I'm shading this, and what I do is I'm now going to cut that right here with some scissors right here. I'm going to take that piece and I'm going to move it over to here, and notice I form a rectangle. Now notice the base, this base doesn't change because all I'm doing is I'm shifting it over here, so this base and this base are the same, they're equal in length. So now I have a rectangle, and recall that the area of a rectangle is simply area equals base times height. Thus the area of a parallelogram is also going to be base times height. So now, given the labeled diagram below, give the formulas for the area and perimeter of a parallelogram. Well, the area is the base, B, times the height, H. And so the way I've labeled this diagram, it's going to be BH or B times H. BH means B times H. The perimeter though, this is side A. That's not the same as the height. So I have two of these A's and I have two of these B's because this also is going to be a congruent base to this. So it's going to be 2B plus 2A. That's the formula for perimeter, the way I've illustrated this figure. Alright, so now let's do an example. Find the area and perimeter of the parallelogram illustrated below. So the area, the base is 16.2 feet. And the height is 5.1 feet. So areas, the area units are going to be feet squared, but I got to take 16.2 times 5.1. So I'm multiplying there. 2 times 1 is 2. 6 times 1 is 6. 1 times 1 is 1. Put a placeholder 0 there. Then I'm going to go 2 times 5 is 10. Carry a 1. 6 times 5 is 30 plus 1 is 31. Carry a 3. 1 times 5 is 5 plus 3 is 8. So now we have 2, 6, 2, 8 when we add it up, and we count 2 places behind a decimal point. So starting at the right, we move the decimal point 2 places to the left. So our area is going to be 82.62 square feet because it's area. Feet times feet makes square feet. The perimeter now is, this is not, the height is not part of the perimeter, it's the distance around the parallelogram. Well, if you look at it, I have two bases here, 2 times 16.2 feet plus 2 times 7.2 feet. So now we do the math, so 16.2 times 2, 4, 6 times 2 is 12, carry a 1, that's 3. Starting, move one place behind a decimal point, so we move one place to the left, that's 32.4, and then we have 7.2 times 2. So 2 times 2 is 4, 7 times 2 is 14. I have one place on decimal point, so it's 14.4. So I end up with 32.4 feet plus 14.4 feet. So now we add those up. Bring the decimal point straight down when we add. That's 8, 6, 4. So the perimeter is 46.8 feet. That's going to be just feet. The area was square feet. All right, let's look at another example. So now I'm using mixed numbers. So the base is 10 2/3 feet, the height is 4 1/2 feet, the length of these sides is 6 3/4. So the area is base times height. So it's 10 2/3 feet times 4 1/2 feet. So what I'm going to do here is I'm going to change each of these to improper fractions. So the way I do that is I take 10 times 3 plus 2, that's 32 over 3 feet. And then this is going to be times 4 1/2 feet. Well, 4 times 2 is 8 plus 1 is 9 over 2 feet. So now we take 32 over 3 times 9 over 2. So notice actually I could multiply it, but I could also reduce it first here, because 9/3 reduces to 3 over 1. Well, 32 times 3 is 96. 2 times 1 is 2. I could have reduced this even more before I started. So I could go with 96 over 2, but let's actually do a little further reduction before we do that. Notice that 32 divided by 2 is 16 over 1. So I end up with 16 times 3, which is 48 over 1. So this is going to be, the area here is going to be just a whole number, it turns out, 48 square feet. All right, now let's look at the perimeter. So I have two sides here, 10 2/3 feet. So I have 2 times 10 2/3 feet plus I have two sides, not using 4.5 here, that's the height, I'm using 6 3/4 feet. So now to do this, I'm going to change these mixed numbers to improper fractions. So that's 2 times, so the way I change to an improper fraction of mixed numbers, I take 10 times 3, which is 30, plus 2, which is 32, over 3, that's going to be feet, plus 2 times 6 3/4, that's 6 times 4 is 24, plus 3 is 27, over 4. So now that's going to be 64 over 3. And then I could write this as, notice I can reduce this to make a little less work. 2/4 reduces to 1/2, so this ends up being 1 times 27 over 2, which is 27 halves. Okay, now I have fractions with unequal denominators. I have to get a common denominator. Well, the least common multiple, which is the least common denominator of 2 and 3, is 6, because the smallest number they both divide into is 6. So first fraction, to make the denominator 6, I need to multiply by 2 over 2. In the second fraction, I need to multiply by 3 over 3. Okay? So 64 times 2 is 128. That's 128 over 6. 21 times 3 is 63. And I should be multiplying this one by, that's right, this is a 2 here, so I'm okay. So that's 27 over 2. So I'm misreading my writing here. Let's get back and do this again. So 27 over 2 times 3 over 3. There we go. So that's 128 over 6. 27 times 3, carry a 2 there, that's 81 over 6. So 128 then plus 81, that's 9, 10, carry a 1, that's 209. So we end up with 209 over 6 feet. The units are feet. That is technically correct, but let's write this as a mixed number. So I divide 6 to get to a mixed number. I divide 6 into 209. That's how you change an improper fraction to a mixed number. 6 goes to 20 3 times. 3 times 6 is 18. Subtract here. That's 2. Bring down the 9. 6 goes into 29 4 times. 6 times 5 is too big. 4 times 6 is 24. So I get a remainder of 5. So to write this as a mixed number, I have 34 whole number parts, and I have 5/6 fractional parts. So this is 34 and 5/6 feet. That's the perimeter. And again, the area was 48 square feet. All right. So now, stop the video and find the area and perimeter of the parallelogram and illustrated below. And then when you're finished, start the video and check to see if you agree with what I got. So the first one has decimals and whole numbers. All right, let's take a look at this. So the area is going to be base times height. So that's going to be 7.8 feet times the height, which is the base, times the height, which is 3.2 feet. So 7.8 times 3.2. I'm going to have to move decimal in the end 2 places, so this is just 78 by 32 for the moment. 8 times 2 is 16. Carry a 1. 7 times 2 is 14, plus 1 is 15. Add a placeholder 0 here, and then go 8 times 3 is 24. Carry a 2. 7 times 3 is 21, plus 2 is 23. So I have 6, 9, 4, 2, move decimal point 2 places to the left, so that's 24.96 square feet. Again, you can kind of check to see if your work seems right, because that's about 8 by 3. 7.8 is about 8, 3.2 is about 3, 8 times 3 is 24, so it looks like we're in the ballpark there. So it looks like gives us further reason to believe we did that correctly. Then the perimeter is going to be 2 of these 7.8 feet plus 2 times 4 feet. Well, 7.8 times 2, 16 carry a 1, that's 15. Move decimal point 1 place left, that's 15.6 feet. Plus 8 feet. So now to add those, you got to be careful. Remember, after every whole number, there's a decimal point. So I could write that as 8 point. I could add a 0 there. So that's 6. Bring down the decimal point when you add. So when you add, you line up the decimal points. When you multiply, you line up the rightmost digits. So be sure you are aware of that. Well, that's 5 plus 8 is 13. Carry a 1, that's 2. So we have 23.6 feet as the perimeter. Okay, last question. So stop the video and see if you can correctly calculate the area and perimeter of this parallelogram. And then restart the video. Okay, the area is going to be base 9 inches times the height 2 1/5 inches. Well, 9, there's no problem there. I'm going to write that as 9 over 1 because I'm going to have a fraction here from this mixed number. That's 2 times 5, which is 10, plus 1 is 11 over 5. So inches by inches, we're going to get square inches. That's going to be 9 times 11 is 99. 1 times 5 is 5. So we have 99/5 square inches, but let's convert that to a mixed number. So I divide 5 into 99. 5 goes into 9 once. 1 times 5 is 5. 4, bring down the 9. 5 goes into 49 9 times. 9 times 5 is 45. So I have a remainder 4. So this is 19 4/5 square inches. That's our area. Okay, then the perimeter is going to be 2 of these 9 inches. 2 times 9 inches. Plus 2 times 4 3/4 inches. Well, 2 times 9 is 18. And then I'm going to convert this to an improper fraction. 4 times 4 is 16, plus 3 is 19 over 4. Notice I can reduce 2/4 to a half, so I'm going to do that before I do anything else. So I have 18. I'll write that as 18 over 1. Plus, then I have 19 over 2. Okay, so my least common denominator 1 and 2 is 2, which is also the least common denominator here. So the first one I have to multiply by 2 over 2. I don't have to do anything to the second one here. Well, that's 36 plus 19 over 2. 36 plus 19 is 55. So this is 55 over 2 inches. Let's write that as a mixed number. So I divide 2 into 55 now to undo this improper fraction. 2 goes to 5 twice. 2 times 2 is 4. Subtract, that's 1. Bring down the 5. 2 goes to 15 7 times. 7 times 2 is 14. Subtract 1. So you get 27 1/2 inches as your perimeter. And this concludes the video.